Thanks for joining us today, Nicolas Frankel. You have more than 20 years Java experience. Last time I saw you live on stage, you presented yourself as a security-minded developer, which I like very much. And I definitely consider you a Java expert with all that experience you have with the VM. One of the things you demonstrated in that presentation was how you can change the type of the class in Java. What is that about?
So we learned, like at least I learned, and probably most of you learned, that Java is a strongly typed language, a statically typed language. So when you declare a variable, it's an int, it's a class of whatever, it's a person, it's a double, it's whatever you want. And then this type is like written into the bytecodes, and well, that's how you can reason about your code, is that once the type is set, then you can use it. If you handle a person with attributes, first name, last name, and you've got an instance of type person, you can query, hey, what is your first name? What is your last name? And at the time, it was possible through introspection, through reflection, so through a Java API, to change the type of a class at runtime. I redid the talk recently. It's not possible anymore in more recent GDKs. So I think it's still possible up to 10. Then in 11, you've got a warning. And I think at 15, there is an exception. You cannot do it anymore. The details are now not in my head anymore, but yeah. So they fixed it finally, but at the time it was very funny that we say that Java is strong, statically typed. Groovy is good, but it's dynamically typed. You can do bad stuff where you could do the same stuff in Java.
So they fixed it, but I guess there's still a lot of legacy systems out there running the old Java. And there was even another thing that scared me even more. And that was, you showed how you can, on a running production system, you can actually change the bytecode to make it do whatever you feel it should do. But in a way, so if you restart the system, all traces would be gone.
Yeah, that's the hacker's dream. So yeah,
yes,
you can actually do that. Yeah, you need another JVM that will attach itself to the first one and inject bytecodes into this first one, or change the bytecode. And yeah, you can do pretty bad stuff. You can do pretty good stuff, but it's like everything. You have a lot of freedom on the JVM. The JVM provides you with so many stuff that it's easy to misuse it. So on one side, you can use it to continuously deliver bytecodes to your production system, meaning that your system never goes down. I have a talk about that. You stream the bytecode directly when there is a change on, let's say, your computer. You can directly stream it to the production system with no downtime. It's just a prototype. But of course, if you are a hacker, you can use the same system to do let's say, to get money on 1 penny on every transaction, or record the passwords, or do bad stuff.
Is that something that was possible with the old version too, but which has been fixed now? As with the first example, it's still possible.
The changing of the type is now impossible, but the attach API is still possible. That's the problem of the JVM, that you have a platform that allows you to do a lot of things. And in most cases, you only need to do like a slide of it. Like most applications, they don't need to do that, but the GVM provides it anyway.
Should I be scared?
Well, you should. You have seen my talk. That was the conclusion of my talk was you can forget everything that I told you so far, and life won't have changed for you. Or you can start thinking that perhaps there is something missing in your setup, and that problem is security. You have this huge platform, you need only a slice, so the rest is just additional attack surface that hackers can use to wreak havoc with the system. And I've shown the way to do it at the time, and it was the security manager. And security manager is also, like, of course, very old. It started with the applets. So the idea was, at the time, you had a GVM and you could run untrusted code on your computer from the internet. And we should provide a sandbox. We should provide stuff that we allows this untrusted code to do, and like permissions to execute some stuff that we allow it to do, and like no permission because we don't want perhaps to read our file system or to access our webcam or to anything. It was a permission system. And the problem is that people still think that the security manager is about running untrusted code, but untrusted code is just code that you download from the internet. The problem is untrusted code nowadays is every library that you're using. Every dependency that you are using is basically untrusted code. The only way to trust this code is to audit it. And I believe that most companies, they don't audit the codes they are using. They don't audit the dependencies. Did anybody ever audit, I don't know, Log4j, SLR4j, like simple, stupid libraries that everybody is using? I believe not. But even if you did, even if you audit the codes, what makes you think that the codes, the source code that you audited, is actually translated into the exact same binary that you are using? The only way to do that would be to not only audit the code, but to build it yourself. Then you can be sure that the binary does mirror the source code. I believe nobody has the resources or the willing to do that. So we are trusting. Of course, there are certificates sometimes, but I don't know if a lot of companies, they are checking the certificates. And you can tell them, that could never happen. Well, it happened in the NPM ecosystem. There was this anecdote.
Oh, yes.
Yeah. So there was this library, I don't remember the name, but the maintainer of the library, it was a very, very well-used library. And he told, hey, folks, now I have other stuff to do. Who wants to maintain the library now? And somebody stepped in. And after a few versions, they realized that there was a backdoor into this library and they were mining cryptocurrencies. They were using your computer power to mine cryptocurrencies. And of course, you can say, it can only happen in the NPM ecosystem because it's just bad. Well, the Maven ecosystem is, in that case, just as bad. Maven or Gradle or whatever, at least the repositories, they are just repository. You can publish it. You can publish your own stuff and anybody can use it. So I'm always using this like example. Imagine you create a library that is really, really useful and people start using it. And at some point you introduce additional capabilities. For example, like steganography capabilities, ability to read like bytecodes in an image. So you would hide a bytecode in an image, or just source code, even source code in an image, and then you would be able to compile it on the fly when the image is read, and then execute the code, and everything is possible. So this whole untrusted codes myth is very like strange that, hey, I mean, untrusted code is just applets. No. So some architectures rely on plugin, but even deeper dependency for me is untrusted codes.
Yeah, and it's like in the Maven universe, does anyone know how many versions of commons logging you're actually including in your project?
That's a good question. I remember when I was still a consultant, at some point, in one of the projects I was an architect of, I started to check the WAR and all the libraries that were included in the WAR in one of my projects. And it took me half a day to, I think I cut the libraries in half, because there were a lot of useless dependencies, redundant, so dependencies in multiple versions and stuff like that. So if you are really willing to do that, it's possible. But even if you restrict the number of libraries, which of course you should do, then again, how do you trust those libraries? Because with transitive dependencies in the JVM ecosystem, which are much better than in NPM, where you have right pad and left pad, I think we are much more sane. That's still a lot of libraries for a simple application, like a simple Spring application, 30 dependencies, 40s, 50s. It's very easy. Some of them are small, some of them are just configurations, some of them actually contain bytecodes. What do you do? And so I mentioned the fact that you would run into a sandbox, and this sandbox was defined by a policy file, and then you would enable the security manager on the JVM, and this security manager by default would read this policy file, and then you would only allow some, or let's say some of the capabilities that you're really willing to allow. Like if you have a web application, probably you want to open ports, which is good. You want to be able to listen to some ports, but why should you be able to access the whole file system? Probably you should restrict the file system to the stuff that you really want to. Like the temporary folder is generally a good default because you do a lot of stuff. Then you should disable compilation, a lot of things like that.
Yeah, this is about the VM. So it's not even a Java issue. Is that correct? So all these other languages like Kotlin, JRuby back in the times, Closure, whatever.
Yeah, this security manager is congruent with the JVM. So you can run any language, because in the end, you don't care about the language, you are running bytecodes.
Yeah.
And Kotlin bytecode can as much access the file system as Java bytecode, because in the end, it's the same JVM API that you are using, or Closure, or whatever. So
it's a very dark picture we're painting here of the VM. What can we do?
Well, one way would have been to improve the security manager, because let's face it, creating a policy file was no work in the park. You want to apply the least privilege principle, so you should start from a blank policy file and add permissions. And for in the presentation, it was just a pet clinic. I think that the policy file was 400 lines long. And this should be done when you create the application, when you update the libraries, when you remove libraries, when you add libraries, whenever you change the application. So this is really a huge downside. And I believe that's one of the reasons that I rarely saw the security manager used. But the Oracle answer to that was, oh, it's too complicated, let's remove it. Well, we don't care about that anymore. You know, the security, you should do your own security. It's not good enough. So let's remove everything and do your own stuff. That's an interesting point of view. And
that's an interesting approach, yes.
Yes, and we were a couple of people saying, hey, perhaps it's not that great. But how can I put it? Let's say that the team was not really interested about feedback. Basically, they told, hey, it will be like this. And the only thing that we could achieve was that now in Java 17, it's deprecated and there is a warning, but it still works. But if you are relying on the security manager, for example, Elasticsearch is relying on the security manager because they have a plugin architecture, well, they should be very afraid because there is nothing else to replace what they had.
I would like to leave a little light in the dark here.
Well, I'm French, so I'm not sure I'm the right person to ask. Like, we are pretty gloomy and we are complaining all the time. The only alternative that I have is just stay on Java 17, which is, well, honestly, for most companies, if they, I believe they are at most are Java 11. So for most companies, it's not an issue. But for companies who which are actually using the security manager, it's going to be an issue at some point. Yes.
It sounds so.
Sorry, no light at the end of the tunnel. I would wish to finish on a slightly more positive note, but actually it's really hard for me to find anything good about this whole stuff. And it's not only about the security manager. It's about the approach that Oracle is taking regarding the feedback. It seems that they are not really community oriented anymore, if they ever were. And I'm a bit afraid, honestly, about the future of, if not JVM, at least Java.
But back in the days, there used to be the JCP work,
yes,
which was very much community driven. Does that still exist?
I'm not sure. And I never was part in the JCP. But for example, it's a side effect, but the Twitter accounts of Java before retweeted a lot of stuff from the community. Like my own articles, sometimes they got promoted by Java when I wrote about Java. But nowadays, nothing comes from the community anymore. It's only about, they hired developer advocates, and they are really good people. I mean, Nicolas, Jose, and David are, I consider them good people, even friends. But it's really like now it's really like on the rails, and nothing should like switch or go sideways. It's very, very like centralized. And I feel it really, it's really sad, really. As a developer now, I mean, again, I've 2 decades of experience. I'm learning Rust. I threw myself into Kotlin already a couple of years ago. So I can say I don't care about Java anymore. I can do my stuff. But for young junior developers, I'm not sure it's really a great idea. It's not a good signal.
Is the problem that Java has turned into a universe that it wasn't meant to be when it was first introduced many, many, many years ago?
Yeah, we can talk a long time about that. I believe, I worked as a consultant for a long time, and I believe that Java was successful compared to Scala, for example, because it was very, very stable. You could run your old Java 1.0 application on Java 1.5, Java 8. For companies, that's the most important stuff. Stability. You want stability at all costs because you don't want to rewrite your application every time you've got a new version. Again, compared to Scala. And now Java has got a huge critical mass. And the strategy has changed a lot. Now they are deprecating stuff. And at first I was happy because some stuff that is deprecated is really like craft, which is good to deprecate. But now they deprecate stuff that actually can be and is really useful and has no other alternative. Worse, the release cadence is crazy. I don't know any company that can get to speed to this release cadence. It's impossible. So unless you are huge enough and you are IT focused, well, you can probably keep up with the cadence. But otherwise, you are doomed. I'm close to Switzerland. I think they just recently upgraded to Java 8. Java
Amazing.
8. Yeah, for God's sake. Of course, administration is not known for being really like moving forward very fast. But I believe they are more representative of the whole industry than companies that can keep the pace with the 6-month cadence. So they are releasing very, very fast and deprecating faster and faster. And so I believe that it's going to be a bigger problem with each release, that it will fragment the ecosystem. We already saw it with the module system. 2 years ago, I think I did an analysis. I took 20 of the most used libraries and checked whether they were compatible with the module system. And I mean, not modules themselves, but just auto modules, meaning you just need to add an additional line into your meta-inf manifest.mf. One line that doesn't change anything. Half of them were not compatible. And so if you want to use modules in your application, then that means that your libraries need to be at least compatible. If they are not compatible, I wrote an article about it, it's a mess. So we saw this great divide, like companies being afraid to move beyond Java 8 because of the modules. And now it's getting faster and faster. So honestly, again, I'm French, I'm complaining all the time. I'm also pessimistic, but I believe that in that case, it's not a great move. I understand that for some people, the most tech-oriented one, it's good to have faster release cadence. But before it was every 4 or 5 years, now it's every 6 months. Perhaps there is a good middle ground, because I think we switched to the other extreme, and it's going to be hard. But let's see, perhaps I'm completely wrong.
But that leads me back to the same question again, because back in the days we had Java 2 standard edition. I guess Java 1 never even existed. We had J2 SE for applications, and then we had the EE edition, the J2 EE, if you wanted to go big scale. And the idea was that everything was in a controlled environment, that the server would set up everything for you. So that leads me back to the question, has Java become something now that it wasn't intended to be back then? Is that the problem?
I cannot answer that question because I started using Java, it was 1.3 for a couple of months, then it was 1.4. So at the time, I didn't think a lot about what was the point of Java or whatever. I was just happy to learn the API. The good thing is, during those 2 decades, I've read a lot of blog posts about Java is dead.
Yeah.
And of course, I found always them very funny because Java is definitely not dead. But this current speed of release might be an impediment for Java adoption, or at least it will definitely fragment the ecosystem. So I know that, hey, starting from Java 9, you can have jar that is multi-released, that you can have like dedicated classes for Java, for each Java version. It just shifts the burden to the library maintainers.
Yeah. Yes.
So again, I'm not super optimistic for the future.
That was a wonderful way to end this conversation. Thank you.
Now I will receive a lot of hate mail from all Java developers from Oracle, but that's fine.
I really encourage everybody to go and check the talk on this link here.
Actually, it's a bit outdated. But it was the time it was recorded. So if you are interested, there is a new version, but it's not on GOTO. So
yeah, it might be outdated, but so are all the Java installations out there. Thanks a lot. Thanks for joining us.